So our next unit, chapter 4, is going to talk about applications to derivatives. So we started that in the end of chapter 3 with related rates. Now we're going to do a lot more with derivatives. The first section we're going to talk about maximum and minimum values of a function. Okay, so just as an introduction, some kind of vocab to go over. I have an absolute, we saw this last year too. I have an absolute maximum, absolute minimum versus a local maximum, local minimum. So your absolute maximum is the absolute highest y value. So when we're talking about maximums and minimums, we're talking about the y value of the function, first of all. Okay, if I were to draw a quick sketch of that polynomial, okay, degree 4 it looks like. So this y value here would be my absolute maximum. There is not another higher y value. So this y value would be my absolute or global maximum. This would be a local maximum. Okay, so in this area it's the highest. And then this would be a local minimum. And it doesn't have an absolute minimum. Why? Because this goes on forever. Okay, so that's just kind of talking about what they are. Now, hopefully we realize that at all of those values, what would the value of the derivative be? 0. Okay, so at my absolute or local max or min, in this specific graph, the derivative would equal 0. Now, more importantly, we'd have to show what does the derivative do? It changes sign. So at an absolute max, what's the derivative doing? It's changing from being positive on this side to negative on this side. And a minimum would be the opposite. Okay, so the derivative is what? Negative on the left, positive on the right. We'll talk more about that, but that's the basic idea. This section is going to focus on absolute max. So how do you find the absolute maximum of a function? And in order to do it, we're going to be on an interval. Because in this case, I couldn't find the minimum because it goes on forever. So we're going to look in one specific interval. Where is your absolute maximum or absolute minimum? Okay, I have here just go to your book and look at the first 4 examples on page 275. It just gives different functions with a simple explanation on maxes and mins. That will help. So please do that. And then I'm just going to continue with this. Okay. So I have a couple theorems. You do not need to know them by name. Just need to be able to use them. And it's kind of getting to the big idea here. Okay. First one, extreme value theorem. If f is continuous on a closed interval, a to b, then f attains an absolute max and an absolute minimum at some number. So if I'm on a closed interval and I'm continuous, then I have a highest point and a lowest point. Now the important thing here is, say I look at this function from here to here. Here's my a, here's my b. Okay, so the highest y value would be here. The lowest y value would actually be at the endpoint here. So that's okay. So if I'm on a closed interval and I'm continuous, I'm going to have a highest point and a lowest point. Okay, that's what that's saying. Okay, next one. If f has a local max or min at c, and if f prime of c exists, then it's going to be 0. We kind of already talked about that. Okay, at a local maximum or minimum, the derivative equals 0. Because why? It has to change from being positive to negative or negative to positive. That's really what we're saying here. Okay, in your own words, you can kind of write that. If I have a local max or min, then the derivative would equal what? 0. Okay, now the opposite's not true. If the derivative is 0, do I definitely have a local max or min? No. Look at x cubed. We know the graph of x cubed quickly. It looks like that. Okay, and I know that at 0, the derivative is actually 0. Okay, and you can actually do f prime is 3x squared, and when you plug 0 in, you get 0, but this is not a local max or min. Okay, so just because the derivative is 0, basically what's the function doing, guys? It just means that the function is leveling out but continuing to increase, or same thing, it's decreasing, levels out, and then it continues to decrease. So you have to be careful. The derivative can be 0 and you not have a local max or min. Okay. We're going to introduce a critical number. What is a critical number? A critical number is some x value where the derivative equals 0 or does not exist. This is important. One or the other. Okay, so a critical number is where my derivative is 0 or does not exist. So where the derivative does not exist. Now we're kind of getting to the point where if I have a local max or min, it's going to be at a critical number. It's going to be where it equals 0 or it doesn't exist. Think about absolute value. Absolute value, the derivative at 0 does not exist, yet that is my minimum. That is my absolute minimum value. Okay, so you just have to be careful. So if I have a local max or min, then C would be a critical number. All we're saying is if you have a local max or min, then the derivative is either 0 or does not exist. So at a local max or min, f prime of x is 0 or does not exist. Okay, and then to actually explain that it's a max or min, you'd have to show that the derivative goes from positive to negative or negative to positive. Again, we're going to do more with that, but I just kind of want to make that known now. Okay. What we're focusing on here is absolute maxes and mins. So to find an absolute max or min of some continuous function on a closed interval, those two things are important. What are you going to do? Well, you just want to figure out where the derivative equals 0 or does not exist, your critical numbers, and then test those values. So I have the steps here. Find your critical numbers. Remember, critical numbers is where f prime equals 0 or does not exist. Okay? Find the values of f at the critical number. So then at those x values, I'm going to plug them into the original function. And I also need to test the endpoints. Because like I showed before, if I have a function, say this, guys, okay, the absolute maximum would actually be here, and the absolute minimum would be here. So it's not necessarily going to be in between the a and the b. It could actually be at an endpoint. So you are going to test where the derivative is 0 or does not exist and the endpoints. And then obviously the biggest number is your maximum, the smallest number is your minimum. So let's go ahead and do a problem. So the first one, find the absolute min and max values. So what do we need to do? We need to find the derivative. So 3x squared minus 6x. And I need to find the critical value. So I need to know where does this equal 0 or does not exist. So obviously it just equals 0. I could take out a 3x, and we get 0 or 2. Okay, so then what? If this has an absolute min and max, it's going to be at one of those numbers or an endpoint. So now you could make a chart. You could figure out at negative 0.5, what does the function equal? At 0, what is the function equal? At 2 and at 4. Okay, so this is my endpoint, and this is my endpoint, and these are my critical numbers. So now I just need to see which one gives me the highest number, which one gives me the lowest. So you would plug these into the original, not the derivative, the original to see what the values are. And if you do that, you get 1/8. F of 0 is 1, f of 2 is negative 4, and f of 4 is 17. So what have we found? The absolute maximum is what? What's the biggest number? 17. Where does it occur? It occurs at 4 at the endpoint, but the actual absolute max is 17. And my absolute minimum value is negative 4. Okay, so it's going to occur at a critical number or an endpoint. If you want, you could stop and you can try the second example. It's just a sine function. Okay, so go ahead. What are you going to do? You're going to find the absolute max and min. And again, every function that's continuous has an absolute max and a minimum on some interval. Okay, so go ahead, find the derivative, which would be what? 1 minus 2 cosine of x. Okay, find your critical numbers, where this equals 0 or does not exist, which obviously this exists everywhere. So I get cosine equals 1/2. When does cosine equal 1/2? At pi over 3 and 5 pi over 3 in this interval. Okay, so then what do? We test all of these values. So I have 0, I have pi over 3, I have 5 pi over 3, and I have 2 pi. Again, critical numbers, endpoints. And figure out which one gives me the highest, which one gives me the lowest. Okay? F of 0 is 0. F of pi over 3 is pi over 3 minus root 3, which is approximately negative 0.685. 5 pi over 3 is 5 pi over 3 plus root 3, which is approximately 6.968. And then 2 pi is 2 pi, which is about 6.283. Notice 3 decimal places. So now, which one is your absolute maximum? Well, it would be 6.968. So my absolute max is my 6.968. And my absolute min, what's the smallest one? Negative 0.685. So that's the highest and lowest it goes on that closed interval. Okay? This is referred to as the closed interval method. This is used what? To find absolute max and minimum. It has one of each on a closed interval. Now your local max or minimums, I just want to make this clear. Okay, your local max or minimums is going to be where? At a critical number, which is where the derivative is 0 or does not exist. And then we're going to talk more about this, but to show that it's a local max, then what? The derivative is going to go from being positive to negative. Okay, so local max, f prime will change from positive to negative, and a local min, f prime will change from negative to positive. Okay, again, we'll do more with that, but I just want to make this clear. Absolute max or min, you're finding the biggest and smallest value, y value, on some interval. Local we'll do more with later. Okay.